Okay, so today we're going to finish up solving quadratic equations by factoring. So this is why I called it 9.4.2 for day 2. Again, as a reminder, we need to make sure that the equation is written in standard form. Then we're going to factor the left side completely, apply the zero product property, or ZPP, and then we're going to write our solution set in set notation using braces. One thing I want to point out today is the following right here. When you factor the left side completely, remember this always starts by looking for GCF. Okay, so you had some practice with that with Friday's assignment, but I also want to remind you, because Friday's assignment kept it pretty simple for you. It was basic trinomial. So today is that's why we're having a second day with practice, because the factoring will get a little bit more difficult. So if it doesn't have a GCF and you notice it has some pretty big numbers, the next thing you should check is if it's a special product. Okay. In particular, the perfect square trinomial. So remember, in a perfect square trinomial, the first term is a perfect square, the last term is a perfect square, the middle term is 2 times the product of the square roots of the two first and last. Okay, we're going to have 2 examples today, so here's our first one. So right off the bat, we need to put this into standard form. So we would add 17n to both sides. And standard form, remember, means that it's in ax squared plus bx plus c equals 0. So when we add the 17n, it's the middle term. So that's 5n squared plus 17n minus 12 equals 0. Okay, now we're going to start the factoring process to the left side. So again, first thing I want to check for, is there a GCF? The answer is no. Then I want to see, happens to be a perfect square trinomial, and the answer is no, because 5 and 12 are not perfect squares. So we're going to have to do, since this is not 1, then it's not a basic factoring, so we have to do the product of the first times the last, which would be negative 60n squared. The middle term adds up to 17n. Since the product of the first and the last term is negative, that means that we're, in a sense, subtracting to get this. So when you have big numbers like this, I want to remind you, in case you've had issues with this before, you should list out all of those factors for this. So like 1, 60, 2, 30, 3, 20, 4, 15, 5, 12, and 6 and 10. And then remind yourself, okay, was I having to add or subtract? Since this product is negative, it means one's positive, one's negative, so we're subtracting to get this. So figure out which one of these pairs over here gives you a difference of positive 17n. Well, that would be this pair, and I would have to make the 20 positive. So it would be negative 3n and positive 20n. All right, continuing on, so we bring this down, 5n squared. We're decomposing the middle term to its inner and outer, so minus 3n plus 20n, and then we bring down the last term. So all those skills that we have already been tested on, we're applying now. All right, now continuing on, we're going to factor by grouping. So this group has an n in common. This group has a 4 in common. All right, and then we look at the 2 terms we have here, and they both have the common binomial 5n minus 3. And then that would be times the quantity n plus 4. I still suggest that you check your factor, okay, to make sure it actually works. 5n times n is 5n squared. Negative 3 times positive 4 is negative 12. The inner term is negative 3n. That's our inner. The outer term is 20n. And that does indeed add up to positive 17n. So we have factored this correctly. Okay, whenever I was checking, I believe the very last assignment, solved by factoring, a couple of you got the message on there, check your factors. And what I was talking about was right at this step. And a lot of times you had the right numbers, but you had the wrong sign. So if you haven't had a chance to go back in and make those corrections, that's what I meant by that. But if you still need to make an appointment with me, please do that. All right, the next step is we're going to apply the ZPP, zero product property. So if this times this is 0, then either 5n minus 3 is 0, or n plus 4 is 0. Then we solve each equation separately, so we add 3 to both sides. So 5n equals 3, divide by 5, so we get n is 3/5 here. Or here we would subtract 4 from both sides, so n is negative 4. Then we're going to write our solution using braces. So the solutions are negative 4 or 3/5. Remember, this is not an ordered pair. It is simply a set of numbers that happens to be the two different solutions we have for this particular example. Okay, here's our last example. So from the beginning, it is in standard form, so we check that off. Now again, I'm just writing this for your notes so you can remember. Okay, then I'm noticing, hey, there's some really big numbers, but you should always check anyway. First, you check, is there a GCF? There is not a GCF. No. Okay, is it a special product? And the answer is yes. And the answer is yes because the first term here is a perfect square, because 9x quantity squared would be 81x squared, and the last term is a perfect square because 16 squared is 256. So I'm going to maybe assume that this is a special product, and then I'll check that it works for the inner term once I have that. So remember, it would be 2 parentheses if it's a perfect square trinomial. We got it from squaring a binomial. So the first term would be the square root of 81x squared, which is 9x. And then since the middle term is negative, it means that both of these are negative because we had to multiply a negative times a negative to get a positive here. And then to get the last term, what's the square root of 256? That would be 16. Okay, but I want to make sure, so I do know 9x times 9x gives me this. Negative 16 times negative 16 gives me this, but I want to check that inner and outer just to be sure. So the outer product is 9 times 16, which is 144x, and the inner product is negative 16 times 9x, which is, oh, I'm sorry, this was negative, which is also negative 144x, so it does add up to the negative 288x, so that checks out. Now, you can leave it written like this, but if you happen to write it like this, I just want to point out it does mean the same thing. Okay, but let's just pretend like you wrote it like this. I really don't care. If you notice, both of these are exactly the same thing. So what that means is that you're only going to have one solution, because why, if this times this is 0, one of them has to be 0. They both are exactly the same, so I'm just going to set up one equation because it's not like I'm going to get a different example by putting or the same thing equals 0. So we add 16 to both sides and then divide by 9. So the solution is, hang on, 16/9. It's just one solution. And remember, that is a possibility. You can have exactly one solution to quadratics, you can have 2 solutions to quadratics, or you could have no solutions to quadratics. The last thing I want to point out that I had to take off for on one of the last assignment is, or I'm sorry, it was the square root assignment, 9.3. is that you guys were changing fractions to decimals and using your calculator to take the square root for you. I'm not going to take that because if we were in class, you would not be doing that, and you won't be doing it later because they're not going to allow you to have your calculator for that. Plus, a really long decimal number really doesn't help us in certain situations. It makes the follow-up process to this even more difficult if we're dealing with like a 20-digit decimal. So please don't forget that.